Hello and welcome to part 2 of the Alibre Design Tips and Tricks video. This is to accompany the article in the June edition of Model Engineers Workshop magazine. I'm going to run through a series of different tips that relate to Alibre Atom 3D, Alibre Design Professional and Alibre Design Expert. I've included timestamps at the bottom if you'd like to jump to a specific part of the video, depending on what you're interested in. Hope you find this useful, and let's get into it. So the first tip I wanted to run through is just to a good bit of advice is generally to keep your part sketches as simple as possible. So I'm currently in a sketch in the part workspace, so this is a sketch that's driving an extruded feature, and a pitfall that I see people newer to 3D CAD get into is they've got a part they're designing, they throw loads and loads of different details into a single sketch, and that can be difficult for a number of reasons. One, the sketch can start to become cluttered and difficult to read. The other thing is that features that are all driven from a single sketch prevents you from controlling the details independently of the base feature. So, for example, you include you could include a circle in here to create a hole. That's fine if it's a straight extrusion, but then if you need to take into account draft angles, you'd very often need the draft on a hole to perhaps go in the opposite direction to the draft on the sort of base part extrusion, in which case you would need to make that as a separate feature. So I'd always recommend not trying to include too many details in your sort of base sketches when you're starting to model a part. So to give you an example, say I wanted a 10mm fillet down this bottom corner, so we can include that in the sketch. There's a fillet tool, so if I go into the fillet tool, set the radius to 10, and then apply that to this corner. Now if I come out of the sketch, that is going to give me a 10mm fillet down the edge of the part. However, there is nothing else I can do with that. I can't vary the fillet along the length. It is just what it is, and it's tied to the extrusion. So I would generally recommend, say, using the 3D fillet tool instead. So in this case, I'm just going to reconnect the sketch. So we're back to our basic part, and then we've got a couple of options. So for example, I could use a variable radius fillet if I pick this edge, and now I've got the option to set the radius and make it different at both ends. So I could say one end wants to be 5mm, the other's 10, and that will give me a tapered fillet. I could even add additional points down the edge if I want to, so set that to say 50 for midpoint and say that wants to be 5, and so on. So by using the 3D tool to drive the feature independently will give you more control, and it also keeps the amount of detail you're trying to include into the sketch itself to a minimum. So I just think that tends to make modeling a bit easier. The next tip I wanted to go through is just to highlight the option for reference figures. So it's very often the case that it's helpful to use some sketch work to perhaps define the position of something else, or as reference over sort of some other feature on the part. Now, if for example, I wanted to find the center of this corner here, I could draw a line across there and then use that to say center a hole on that position. Unfortunately, if I come out of this sketch now using sketch figures, we're going to get an error because I've got an overlap of sketch figures, and Alibre doesn't allow that in most of its tools. So if I edit the sketch again, what I need this line here for the construction, but I need it as sort of like a construction line rather than something that's being used for the 3D feature. So to do that, I can just right click on this, and we've got an option here called convert to reference figure. So reference figures in Alibre are basically Alibre's form of construction lines, and you can include them in a sketch to, in this case, for example, position something, or just use it as reference for something you're working around without them actually being involved in whatever 3D procedure you're trying to do. So if I now deactivate that sketch, you'll see that there's now no problem because the reference line isn't considered for the 3D geometry. If I go back into the sketch quickly, as well as converting any type of figure to a reference line, for example, we can do that with circle, we also have a section here where we can directly create reference lines. So if I wanted to draw another reference line down in this bottom right section, I can just draw it directly. And if I drew a reference line in and then realized I needed that to be a standard figure to be part of the 3D feature, I could just right click on it and we have the convert to regular figures option as well. So it's just something to be aware of that can be really handy when you need to include something but don't want it to be part of the 3D operation. So the final tip on sketching I wanted to run through is just a quick explanation of the Alibre's constraint system. So I'm just in a new part in a blank sketch, and for example, I'd like to draw a pair of lines at 45 degrees. So if I go into my sketch figures, I can start off. I'm going to start a line on the origin point there, and I'm going to use a dimension to set that angle to 45 degrees. Now I'm going to draw a second line in, and I would like this line to be parallel with the first one. Now I could add another 45 degree dimension, but that's a pretty inefficient way of creating a sketch, and certainly as your sketches get bigger, you're going to start adding in more features. Having dimensions on every single line is going to get quite messy. So what we can do instead is use one of the constraints. So on the sketch toolbar, constraints are in sort of in the middle of the toolbar here, and there's a whole range of different options, and these basically apply geometric conditions to lines instead of just relying on dimensions. And this option here on the bottom is parallel. Now if you move the mouse over any of these constraints, Alibre's got some really good tooltips that explain what it does and gives a brief explanation of how to go about using the tool. So for this example, we can use parallel. So if I click on that constraint, I'm now going to select the 45 degree line we've created and then click on the second line we want to make parallel to it, and then I'm just going to click into empty space to unselect. So we've now made those two lines parallel. If I now edit this dimension, the constraint will mean that the two lines work together. So the constraints are a really good way of allowing you to describe design intent of sort of how these figures should relate to each other without just relying on dimensions. And so I'd always recommend, if you've got several things that are parallel or you've got things at the same size, is to dimension once and then use the appropriate constraint to apply that to the other related figures. So it's sort of things you can do in here. We've got concentric if you need to center circles in each other. Equal constraint will make things either lines the same length or circles the same diameter. We have a symmetry constraint if you need to make two figures symmetric about an axis. So there's lots of powerful options in there to allow you to sort of simplify your sketches and capture that design intent. So for this next set of tips, I'm going to run through how to get the best out of the Alibre assembly workspace. So to start with, I'm just going to start a new assembly. And when you open a new assembly, Alibre asks for us to select a component to use to start the assembly. So I'm just going to use the box that we've been working on. So I'll go OK, open. and then I'll just left click to place one copy of that into the assembly and click finish. And I'm just going to rotate round and zoom out a bit. So there's our component in the assembly. Now, something I find that a lot of people who are new to assembly modeling can struggle with is the fact that you have to fix the first component in the assembly in position before you add additional components in. So if I just left click and hold the left mouse button and drag on a face of the part, you'll see that at the moment this is completely free to move in relation to the assembly coordinate system that we're given. There are a number of tutorials that suggest that you can just anchor the first part. So for example, if I select a face of this, I can use the anchor command and that will just fix the part in whatever position it happens to be sitting in. If you're really struggling, that might be an option you could try. However, personally, I think it's a good idea to align the first component you're bringing in to the assembly XYZ planes that you're given, so that it's actually sort of sitting in a sensible location. Otherwise you've got this sort of reference system with a part sitting at some sort of arbitrary position. So in order to position this first component, what I'm going to do, if I right click on the component here, we can turn on the reference planes, and that's the construction planes we used in the part workspace to build the part itself. So if I check that option on, and you see that the part reference planes are shown in sort of this orangey color. Now what I can do is, if we use the assembly constraints tool, I can then apply constraints between the part reference planes and the assembly references, and then that will just center this part within the assembly. So if I start off here and pick those two planes, the two XYs, that will then create a coincident constraint, which is fine. So I'm happy that I hit apply. I can then do the same with the two YZ planes here, hit apply, and then finally create a coincidence between the two XZ planes, hit apply and close. If I now left click and drag on a face of the part, that will no longer move. So we've successfully constrained the first component in the assembly. And at this stage now, I'm just going to right click and uncheck the show reference geometry option, just for neatness, as if you start bringing multiple parts in and leave the part reference geometry on it, the assembly can get quite busy. The next tip I wanted to run through is how to deal with a part that you bring into assembly and it's in completely the wrong orientation for how it needs to be fitted to the rest of the assembly. So for this, I'm just going to go to Insert Design, and I've got a lid component here that's sort of just designed to fit this box, and I'll click to place one instance of that in the assembly and then click Finish. Now as you can see, the lid is in completely the wrong orientation. Now one thing I see a lot of beginners run into, a problem they run into, is the fact that they will spend quite a bit of time sort of spinning parts around and sort of manually repositioning them to get them into the right orientation before applying any constraints. So in Alibre, if you hold the shift key down and drag on a part, you can sort of rotate it. I'll just undo that. There's also this component placement tool that if I then click on the part, we get a sort of dolly system that allows you to spin the part round. However, as you get more comfortable with assembly constraints, you'll actually find that by simply applying the correct constraints to the part, it should end up in the orientation it needs to be in without you needing to reposition it. So in the case of this lid, I'm just going to go into the constraints. I'm going to leave it exactly where it is, and then I'm just going to apply the constraints I need to get this lined up. So first one is that we've got this little hinge arrangement, so I'm just going to pick the cylindrical face on the little hinge point on the lid, and then with this lid is fitted onto the part, that hinge point would line up with the hole on this side. So I'm going to pick the cylindrical face on this side of the box. Now Alibre has created a coaxial constraint, so it's lined the two holes up. However, the lid is currently sitting sort of rotated 180 degrees from where we need it. So in the Assembly Constraints tool, we've got this flip orientation button. So if I click that, sometimes you have to click it twice, there we go, that will then reverse the orientation of that coaxial constraint and flip the lid round to the direction we need. So with that done, I'll hit apply. Now I'm just going to pick the two faces, the face on the edge of the lid and the face on the edge of the box, to line those two up. Hit apply, that's okay. So now if I click and drag on the lid with that alignment and the coaxial, the only remaining degrees of freedom as it is that the lid can pivot on the hinge point there. So I'm just going to sort of leave that slightly open, and then I'm going to rotate round, and I'm going to pick the flat face on the underside of the lid and the flat face on the top of the box. Now that's gone to a coincidence, which is okay if we wanted the lid closed, but I'd actually like to be able to control the angle the lid's sitting at, so I'm going to just change my constraint type to angle, and I'm going to set that to say 150 degrees. I could increase or reduce the angle depending on what position I'd like to show it in, but I'm happy with that, so I'll hit apply and then close. And so as you can see, we can quite easily bring a part in and get it fitted to the assembly in the right position simply by applying the appropriate constraints without needing to sort of manually reorient the part to begin with. The final tip I'd like to run through with assemblies is something that's referred to as in-context editing. So in this case, what we're talking about is the ability to edit a part that's in an assembly in the assembly itself, so that you can see what you're doing in relation to other components, rather than editing the part in a sort of on its own or in a separate window. So to do that, let's say we want to add some reinforcement to the side of the box around where that hinge point is. So if I just right click on the face of the box, there's an option called Edit Here. If I click that, what you'll see now is that the ribbon toolbar and Design Explorer we've now changed to the part workspace, but you'll note that we can still see the lid, and that in the tree we do still have the assembly listed. And basically what it shows is that the block component we're working on is shown in blue to say this is one we're editing, whereas the lid is sort of just nested at the bottom. So now we can work on the part as normal. So let's say I want to put a feature on this side to reinforce the side near where the hinge is. So I could select that and go activate 2D sketch, and I could draw a sketch, create a feature. But something else that's useful is, because we're working from within the assembly, I can actually pull references from the assembly itself. So I've got a function here called project to sketch. So if I go into that, this allows me to pull features from other things, either in the part itself or in this case from other components within the assembly. So for this, I'm just going to pick this edge of the hinge here, because it would be useful to know what size that is, so that I make sure I could make my support feature fit around it. And I've got a couple of options in this box to choose. I can choose whether I want to create that as just a standard sketch figure or just as reference. So in this case, I think reference would be more useful. And then there's also this checkbox for maintain association. So if I was to turn maintain association on, that would actually link this feature in this sketch to the lid itself. And when you go back into the assembly, it would actually create what's called an inter-design relationship. Now, those can be very useful if you are wanting to drive the dimensions of one feature from another component. However, they're also quite easy to break, as if I was to change something on the lid, or remove the lid and put in a different component, then that would break that relationship. So what I tend to do is I'm going to pull it through as a reference but not maintain association, so go OK. So then that's just put a reference geometry in the right place, but it isn't fixed. So in order to maintain its position without deliberately linking it to the part, I'm just going to add some dimensions as exactly where it is, so I won't change them. And that way I've pulled through the reference of the position of that edge of the hinge but I haven't actually linked the two together because I don't want that dependency in the model. Now I can use that as a starting point to build a new feature. So for example, I can draw an arc and I'd like to make a little reinforcement that's just a little bit bigger than that, so there's a bit of clearance. So I can put that arc feature in there. I could then dimension between the reference we've created and the arc and say, oh, let's give it 1 mil of clearance. And let's see, I'll just draw in sort of little support piece here. There we go, that's fully defined. Just use that to create a little extruded support. And sort of, as we were saying in some of the tips in the first video, I just rather than I could draw it and extrude it to the other side, but actually we can just cheat and use mirror to copy that to the other side of the part. And now I'm happy that we've got our feature, so I'd like to go back to the assembly environment. So to do that, I'm just going to right click on where the blue part name is in the tree on the left there and just uncheck edit part subassembly. And now you see that our toolbars go back to the assembly workspace. So this last set of tips, I'm going to run through a few useful tools in the Alibre drawing workspace. So I've got a drawing here on a standard ISO A4 template. I've just got a side view of the sort of box and lid assembly we had earlier. And one really useful option is the ability to add centers to an individual hole or radius. So when you create the views, there is an option to bring all centers through for the view, and you can also do that by just left clicking on the part, go manage view and centers. But as you can see, that's put centers on every single hole, which for a more complex part can get quite busy. The other thing that that option doesn't do is it doesn't bring through centers for arcs. So for example, if I needed the center for the radius there, the auto hole center function doesn't provide that. So I'm just going to go on here and click minus to just remove the centers. So if I want to add a center to a specific hole or to an arc, all you need to do is move your mouse over the edge that you want to of this circular figure you want to add a center to, right click and go insert center. And then similarly that also works for sort of arcs and radiuses as well. So I can add one in there and say I wanted to just dimension one of these holes. So that's just a useful little tool. As I say, it allows you to selectively add centers to the drawing rather than adding centers to absolutely everything or none at all. The next thing I wanted to run through is the activate sketch in view capability. So something that can be quite useful. There's times where you're doing modeling where there's a detail on a part, say something like a logo or a surface texture or something like that, that isn't really practical to model in the 3D workspace. So if we do need to, so it's useful to be able to sort of draw over the top of a drawing view to sort of add additional information in. So if I wanted to do that, all you need to do is move the mouse over the view you want to edit, right click and go activate sketch in view. This then brings up the full set of drawing tools similar to the tools available in the part modeling workspace, and from here I can use these to draw and on top of the view here manually. So for example, And so use a spline here, I could sort of indicate that there's a logo or something like that there. Whatever I want to draw. And when I'm happy with the changes I've made, I can just deactivate sketch. And now if I move this around, you'll see that because I was sketching on this view, that will stay linked to the view itself and we'll go with it. And then I could, for example, use the note tool and sort of show a leader and sort of say, you know, logo here or something like that. So it's a useful way of being able to edit views. It's also possible, if I don't select the view and just click on some empty space, to go activate sketch on sheet. And then that brings me back into the part tools, but sketching just on the page itself. This can be useful. So if you import an AutoCAD DWG or DXF file into Alibre, it will open it in the drawing workspace, and actually using the sketch on sheet function, you can work on a 2D drawing and edit it. So it is actually possible to use Alibre Atom or any of the versions of Alibre as a basic AutoCAD drawing editor if you need to. Click deactivate sketch, and if you were doing that, you can actually control the you do have dimension styles and layers options in here, so you can control the line work styles and whatnot. Now the final thing I wanted to run through is what to do if I wanted to make a change to the part and then update the drawing. Now you can, if Alibre doesn't update the drawings all the time, it will reproject all the views when you open the drawing. So commonly you're working on the parts, and then when you're finished, you open the drawings up and make some updates. However, if you're working on something and notice something that needs to change, it's sometimes useful to be able to jump into 3D model, make a change, and then you want to see what happens on the drawing without having to sort of close and reopen everything. So it is possible to do that. So as a example, I'm just going to jump into the 3D model, and let's just edit this box here. I'm just going to add an additional hole to it. So let's just stick something down there. So I'm happy with that sketch. I'm just going to make that a through all hole. So I've got a hole in here. Now the first thing is, before I can update the drawing, I need to save the change to the part within the assembly. So I'm just going to come out of the assembly mode and save. So that's going to update the part. And then I'm going to close that and go back to my drawing. Now as you can see, the drawing hasn't updated yet. Now that's where this reproject views option comes in, but before we can do that, we need to save the drawing. So I'm just going to go up and hit save. Save my drawing there into my folder. Now I'm going to hit the reproject view option and then just go OK. What that's going to do is force Alibre to reassess the drawing, and then you can see it's updated and brought through the new hole feature we added to the assembly. So that's everything I wanted to run through in this second part of the Alibre tips and tricks videos. Hope you found some of those useful. If there's any other features of the software that you'd like me to run through, please leave me a comment. Thank you.